In mathematics, Gaussian elimination, also known as row reduction, is an algorithm for solving systems of linear equations. It consists of a sequence of operations performed on the corresponding matrix of coefficients. This method can also be used to compute the rank of a matrix, the determinant of a square matrix, and the inverse of an invertible matrix. The Gaussian elimination method refers to a strategy used to obtain row echelon form of a matrix. The goal is to write matrix A with the number 1 as the entry down the main diagonal and have all zeros below. The first step of the Gaussian strategy includes obtaining a 1 as the first entry so that row 1 may be used to the other rows below. To perform row reduction on a matrix, one uses a sequence of elementary row operations to modify the matrix until the lower left-hand corner of the matrix is filled with zeros as much as possible. There are three types of elementary row operations. First, swapping two rows. Second, multiplying a row by a non-zero number. And the last is adding a multiple of one row to another row. Using these operations, a matrix can always be transformed into an upper triangular matrix, and in fact, one that is in row echelon form. Once all of the leading coefficients, the leftmost non-zero entry in each row, are 1, and every column containing a leading coefficient has zeros elsewhere, the matrix is said to be in reduced row echelon form. This final form is unique. In other words, it is independent of the sequence of row operations used. For example, in the following sequence of row operations, where two elementary operations on different rows are done at first and third steps. The third and fourth matrices are the ones in row echelon form, and the final matrix is the unique reduced row echelon form. Using row operations to convert a matrix into a reduced row echelon form is sometimes called as Gauss-Jordan elimination. In this case, the term Gaussian elimination refers to the process until it has reached its upper triangular or unreduced row echelon form. For computational reasons, when solving systems of linear equations, it is sometimes preferable to stop row operations before the matrix is completely reduced.
The Matlab program of the Gaussian elimination algorithm can be done in various ways. The first part of the code will check the values if it is equal to 0 or not, and the loop function to check all the values inside the matrix, and then proceed to the elimination process of those numbers which is not 0. The second part of the program is back substitution, wherein the program used the updated augmented matrix data to solve for the value of the unknowns. The program will be as follows.